Hi everyone, Brian Cox here from Future Vision Research, and in this video I'll show you how to make the Alabama Rocketry Association 2025 Learn to Solder badge. Let's get started. Now here's the parts that you need. Of course, this all comes in each little kit bag. You need the printed circuit board, and you need the little slide switch, a battery holder, 2 resistors, and then 2 LEDs. LED stands for light emitting diode. A couple of notes, the light emitting diodes are fast color cycling, so they'll actually flip through a whole bunch of colors automatically without any external circuitry, except of course the resistors to limit the current flow. And these are the resistors, switch, and LEDs are example of through-hole parts that will go through the circuit board. The battery holder is an example of a surface mount part. So you get a little bit of practice in soldering both kinds of electronic components. Now, what else is going on here? I give you 3 clothespins. These are really useful for acting as a basic solder stand, and they can hold parts in place as you solder them, and I'll show you how to do that. We have a CR1220 battery and then an alcohol prep pad. And this little wire is like a luggage tag that loops in on itself, and you can put it through this hole so you can clip it to your backpack or whatever else you like. So let's go ahead and get ready to get started. You need to use a regular electronics soldering iron to build this circuit. You can use one that has a fixed medium temperature, or you could use one that has a variable temperature. I'll be using a variable temperature iron from Weller. If you do have one that needs you to set the temperature, then you want to use a range of 325 to 375 Celsius or 617 to 707 Fahrenheit. I'll have my iron set for 350. The idea is we want the coolest temperature possible that will properly heat the leads and the circuit board to allow the solder to flow or wet over the entire connection. So with the parts we're using, 350 Celsius should be ample. In addition to the soldering iron, of course, you need some solder. And I like to use 6040 rosin core solder, and more specifically, no clean solder. By using rosin solder, then the rosin helps clean the connections as you solder the circuit board. No clean means you don't actually have to clean off the residue, but it is best to do it. You can use then rosin cleaner or isopropyl alcohol, and a soft brush like an old toothbrush works fairly well. The other kind of solder you'll encounter would be lead-free. I don't like using lead-free when students just get started because it requires a slightly higher temperature, and I find that lead-free solder is a little harder to learn with. But if you're at a school that requires no lead, then you'll have to use that and set the temperature accordingly. I also recommend having a brass brush like this. This is like a SOS pad, but it's made out of brush. This will be used to clean the soldering iron tip. Before you apply your tip to the circuit board, you want to rub the tip in the brass solder, and then once you apply your solder and solder a connection, then you're going to wipe that again before you put the soldering iron back in its stand. By the way, always put the iron back in its stand. Never have the habit of just setting the iron down on your bench. Very unsafe. Now, speaking of sponges, some soldering irons come with a sponge that you actually get wet. And the idea with that is you run it under some water, squeeze it out so it's just moist. But I don't like using a wet sponge. One, it thermally shocks the iron. And then 2, it lowers the temperature of the iron temporarily, and I find it does not clean as well. You want your tip to look like this. Nice, let me make sure it's in focus. Nice and shiny on the tip. If it is not shiny like this, then it's not going to heat up everything properly. If you find that you have soldering irons that do not have a nice shiny tip like this, then you want to get some tip tinner. Tip tinner, once an iron is heated, then you actually just rest it in the tinner and it will clean up residue from the end. This actually has some acid in it, so you do not want to leave the tinner on your iron. Despite the name, it is not for tinning. Tinning also describes the process of applying solder to the iron. So now that I've used the tip tinner, I'm going to use a brass sponge to wipe that off. Okay, I think we're ready to go. The order for installing the parts will be first, we'll do resistors. I like to start with parts that are lowest on the circuit board first. So we'll start with the through-hole resistors, and then we'll do LEDs. Those are applied from the side with the logo. And then after that, then we'll turn it over and we will do the slide switch and the battery holder, install the battery, and we'll be done. So let's go ahead and start with the resistors. Now, here's your resistors. Let me see if I can zoom in a little bit closer. Resistors have a color code, and the color code represents 15 ohms, and both resistors have the same value. Now, resistor is not a polarized part, so it technically does not matter which direction you install it. However, best practice is to install the resistors so that you can read the color code the same direction that you would read the value printed on the actual circuit board itself. Now, the value I put on the back, so you would always be able to see it even once you solder your part. But we also have the designator, which is R1 and R2. So we'll install the color code the same direction. How do you read the color code? Well, with these are 4 stripe resistors, and you put the metallic color on the right. So the gold, which is tolerance, is on the right. So that's how we'll install it, with gold on the right. When you install the resistors, you want to form or bend the leads down so they will go through the hole. You have lead forming tools like this, where all you do is you lay the resistor right in the little slot, and then you fold the 2 leads down. Let me zoom out a little bit so it stays in focus. Once you form the leads down like this, like a staple, oh, I forgot a step. Before we install this, I got ahead of myself. It's best to clean your circuit board with isopropyl alcohol before you start soldering. So each of my kits comes with an alcohol prep, and we're just going to run it over both connections. I just do connect all the solder points on both sides. This helps remove any residue from the manufacturing process. I've even seen some boards come where it's almost like a thin powder over the whole board, and that will make a dirty connection and will make it more difficult for the solder to flow. Okay, so now we've cleaned that, and then we'll just dispose of that properly. That's why I was wearing the glove. We'll take the glove off, and we'll come back to the resistor. So here's the first resistor, and I will press it through, and we just are setting it through the 2 holes, and then it should lie flush. So here we can see, I'll zoom in if I can just a little bit. Here's the first resistor in place, and you can see gold is on the right. And now the 2 leads are pressed through. So what you want to do is then press down on the resistor and splay or bend the 2 leads away from each other like this. That helps hold the part in place while you solder it. And we'll go ahead and just put in one part and then solder it, then we'll go from there. I'm now going to turn the board over, and this is where the clothesline clips come in handy, the clothespins. So I'm just going to find 3 places that allow it to sit comfortably so that the board is stable. So you can see now it's not going to go anywhere. When you solder, by the way, feel free to rearrange the circuit board in a direction that is most comfortable to get at the connection. Now, how about the actual process of soldering? Believe it or not, in soldering, you are not heating up the solder directly. Instead, you are heating up the pad, which is the little circles on the board, and the lead. You're making them both hot enough so that the solder will flow or melt onto that. So let me get a little bit more light on here. So here's the process. We bring in the iron, and I'm resting the iron tip, which is already up to temperature, on the circular pad and on the lead. And now I will actually bring in the solder, and I'm just barely touching it to the tip of the iron, but then I'm actually feeding it onto the pad. And what we're doing is we're watching the solder flow all the way around the pad, plus, or I should say pad, and then slightly up the lead. So I fed solder, took the solder away, and then I take the iron away, and that is a completed connection right there. And we would say that is a properly wetted connection. And I'm going to see if I can get it in focus for you here. Yep, so there it is. Now, you may have noticed a little bit of smoke. That's natural. That's the rosin core, the rosin, the cleaning material that's smoking away, and then you can see it leaves a little bit of residue on the board. But this is rosin core, so it's not conductive, so it's okay to leave it there, but ideally we would clean that off with isopropyl alcohol. So now that I've done one side of the resistor, I will do the other, and so that's the process. Rest the iron, let it heat up the joint, bring in the solder, touch the iron slightly with the solder to get it start melting. Notice the iron stays still and the solder is what you move. I'll take the solder away and I'll take the iron away, and that connection is done. A properly soldered connection will have solder all the way around the pad and then climb slightly up like a little volcano, slightly up the, I shouldn't say volcano because volcanoes have a crater. If you have a crater, that's bad. So let's say like a little mountain, a little hill with the solder climbing up the lead. And as I look at both of these could technically use a little bit of solder. Now, one of the things to keep in mind is these are really nice circuit boards, if I do say so myself, and the pads actually have pads metal on both sides of the board, plus they have a little tube going through the hole. That means solder will actually travel from one side of the board, bond with the entire lead, and then come out the other side. So you want to be careful when you're feeding solder that you don't feed so much that it just creates a ball of solder on the opposite side of your circuit board. And that's all part of the practice of deciding and learning how much solder you need. Now you may notice also that I have a wedge tip. It's not quite a screwdriver tip, but it's slightly flattened. So as opposed to a conical tip, with a wedge tip, we want to make sure that we're lying it flat. This is the one I find that I prefer. And so then we will do this there and get that a little bit more solder. Okay, and that's it. That resistor is now set and ready to go. You want to wait a moment before you take away before you clip the leads, because remember, everything's going to be hot. So let me just show you how we would trim those leads. Now, let's look at the solder connection. How is the amount of solder with these? Well, I would say technically, this one on the right has a little more than I would prefer. This is a cleaner connection. The solder travels all the way around and then slightly up the lead. This doesn't have a ball of solder, but so I would say it's still okay, but it is a little bit more than we need. So you just kind of just with practice, we'll learn how to do that. Now what you want to do is use flush cutters, but don't let the name fool you. These would be flush cutters or diagonals. You are not cutting the lead flush. We do not want to damage the solder connection. So what you're going to do is leave 1 to 3 millimeters of lead, probably closer to 1 to 2 millimeters of lead, sticking out of the solder when you trim the leads. And then I like to have the habit of using my finger to guide the lead that I'm trimming. Otherwise, you could shoot it across to a neighbor, which you don't want to do. So the idea is these leads need to be short enough to where they're not going to bend over and short against another part. So sometimes you might trim them a little bit. Just be sure you are not trimming the solder itself, because that would mess up the joint. Okay, let's do the other resistor. Now I mentioned using a lead forming tool, but another method that you can use when you're bending your leads is to actually just use a pair of needle nose pliers. But keep in mind, you're not really bending the leads, you're just using the pliers to hold the pin while you do the bending with your finger. So what we'll do here is we're going to hold the resistor up against the location where it's going to go. I'm confirming that I have gold on the right, and we can see that the spacing's not super wide. So I'm going to hold my needle nose right up against, and then I'm actually using my finger to press it over. And then I'll do the same thing on the other side. And let's see how my spacing is. Sometimes you may have to redo the spacing if the resistor will not settle right in. Okay, I was fortunate this time. The resistor is sitting all the way flush. I will splay the leads away from each other. By the way, if you splay the leads on a resistor, you should not really need to hold them in any other way. That will hold on sufficiently. Let's put our makeshift stands right back in place, in a place that's convenient. Try like that. And you can really clip them wherever you want. And same process. My iron, of course, has remained heated this whole time, so I will hold the iron against the pad and lead. Slightly tap the solder to the iron, but then move the solder around. Take the solder away, and then remove the iron. There's one connection. Same process here. Now, this becomes a little bit of a muscle memory. One of the most popular things that happens is you accidentally remove the iron instead of the solder, and now your entire spool of solder is stuck to the board. Not a big problem. What you can do is just bring your iron back in and reheat it. But if you apply too much solder, let's say you just end up with a big ball of solder, you will have to use either desolder braid or a solder vacuum tool to remove that extra amount. One quick tip with solder braid, if you use it, just trim off a little piece of the braid. Don't leave it connected to the spool. That means, and I don't have a piece of braid handy, so I won't interrupt the video to do that. But if you use a long piece of braid, that means you're using a lot of heat to try to heat up the entire braid, and it won't work as well. Okay, that was just a little side note about desoldering, but we're focusing on soldering right now. So when should you trim leads? Trim leads, one, after you've confirmed that the part is really where it's supposed to go. It is much easier to fix a part, desolder it, and remove it when the leads are long. Once you've confirmed, then you could trim it as you go, or once leads start to get in your way. I will just go ahead and trim this other resistor now. And there we have it. There's both resistors. Now that we've done the two resistors, we will do the two LEDs. Now, LEDs are a polarized part. Remember, light emitting diode. And there are three ways to tell physically on the LED. Two are guaranteed. For most LEDs, the shorter lead is negative. If you can, and I guess I will say on most, flat against the bezel, the plastic part, there will be a flat spot, which is also negative. And then if you can see inside, the larger frame inside is often negative. But the most guaranteed way to know is the shorter lead on most LEDs. And on the symbol, on the circuit board, it's a little bit hard to read because of the logo, but there is a flat marking down here on the bottom part. Flat marks negative, but then on the back of the board, what I've done is I've marked positive, which is the top. Notice also that the negative lead is a square pad, positive is round. So what does that mean? Well, we're going to take the LED and install it short lead down, negative down, into the square peg, or I guess I should say square pad. I'll hold the LED flush, and then from the back we can see the long lead. Let's see if I can hold this in a way where you can tell on camera. The long lead there is in positive. So we will hold this flush, and now we'll bend these two leads away from each other. Now what I like to do when I'm doing the LEDs is I like to actually rest the board on top of the LED so that it's pressed all the way. And then I'll just use two of the holders to kind of hold it stable. And now we go through the same process of soldering those two connections. Just be really sure that you have the polarity correct. The most common mistake in building these is having the LEDs in backwards. All right, so I will hold the iron against the pad, touch the solder to the iron, and then feed a little bit more solder, take the solder away, take the iron away, and there's the connection complete. Let me bring this up here a little bit. And then here's the other. So I'll wait for a moment to trim the lead. Notice I leave the iron in place for a moment. That allows the solder to settle into place and will make sure that the part is uniformly heated. And before we trim leads too, we want to double check and make sure that the LED is flat, flush like that. Okay, let's take the other LED. So short lead towards the flat portion of the symbol. Looking from the back, and it fell out accidentally, no problem. Long lead into the positive, and then short lead into the square pad. So it looks like we're good there. So I'll bend these away from each other. But I'll do the same thing. I'm going to rest the circuit board on the LED to hold it in place. You'll notice in the parts list, I list masking tape. If you don't have helping hands that can be used to help hold parts in place, then you can use masking tape as another option too. Okay, so I think we are good. That LED is resting here. And then we'll do the same process here. So I'm going to rest the iron, solder that, do the other side, and there's the other LED. And so we'll double check, make sure both LEDs are flush, and they are. So now we'll trim these leads. So with these two resistors and these two LEDs soldered, we are done with the front of the board. So now we'll turn it over and keep going. Up next will be the slide switch. Now the slide switch is the smallest part that we have. And the direction it will face is, first of all, make sure you're looking at the back of the board where you can see the Future Vision Research logo here. And you can see the outline for the battery. The switch will install from this side and put the little knob of the switch towards that little symbol for the knob towards the edge of the board. And then what you'll do is you'll line up all, 5 holes, and then the switch will slide into place like that. Now I purposely use a switch that has tiny little clips to help hold it in place. So once you put it in, it should hold itself there. So let's see how that goes. I'm going to use my clothespins again. When you solder this, let's see if I can zoom in. You want to solder the 2 outside connections of the switch first, and then confirm that it's sitting flush, and then solder the 3 inside pins. So let's try that. Bring in the iron. And notice I'm not pressing on the pin, I'm resting the iron next to it. And then I'll bring the solder in here. And there's one side. So I'm just touching the tip of the iron to start the solder melting. Okay, and these will look like a little ball of solder here. That's because these leads are quite short, and that's okay. So how does it look? The slide switch is still sitting flush. And be careful, this is going to get quite hot, so don't wait a moment before you touch it. Now that we've soldered the 2 outside connections, we can do the 3 that are in the middle. One. And it takes a while, a moment longer before you'll see the solder begin to melt. That's because the iron is heating up the entire switch so that the lead will be hot enough to melt, I should say. Okay, there we have it. So this, don't hesitate, by the way, too, to grab a magnifier if you need to. And in a pinch, your cell phone camera can work as a little magnifier. So I'm just making sure to reheat that. And that's it. The slide switch is going. And while you're here, by the way, go ahead and slide the switch so that it's in the off position. That way you'll be able to have your triumphant moment when you turn the switch on to see the LEDs go. Switch is done. What's remaining? Remaining is the battery. Now, batteries, of course, are polarized, positive and negative. And you can see from the symbol gives you the outline for this actual battery holder. The battery also has 2 little pins which will sit in those 2 little holes. Those are registration pins that help it settle into place. What we'll do is we'll take a clothespin and then we clip it right on top. And then what you want to do is look at the 2 tabs here, and there is a little bit of play with the registration. You're basically looking to make sure that the 2 pads are as close to the middle as you can, let's see, for these 2 pads so that the solder will flow. What we're going to do in this case is we're actually going to rest the iron right on top of the pad, or I should say even the tab, which will then heat up the pad underneath, and this is a trick for doing surface mount parts. So I will use the other 2 clothespins to help stabilize here. And I need to clip it on a place where there's no pins. Okay, I think, yeah, so one of the things that is happening in this case is the LEDs are now kind of creating a teeter point. So you could just even rest the entire badge on top of these if you find that that's easier and gives you a more stable surface, as long as you're using one of these to clip on. Okay, I'm just going to find a nice way for this to rest. I think I'm satisfied with that. Okay, so what do we do here? We have the battery holder in place. So I will rest the iron on top. And then what we're going to do again is just tap the solder just slightly to the iron. And then we will feed solder onto the pad and onto the lead. And then we'll take the iron away. And now we have essentially a little rectangle of solder that slightly bulges away from the board. And that is a successful surface mount connection. So I'll make sure you can see this on camera. And then we'll do the same thing over here. Now I'm noticing a little bit of residue on my tip, so I'm going to come back over to the brass sponge and wipe that off. The clean tip means more heat transfer. And then I'm going to rest on top of this pad, heat it up, and remember, we're moving the solder, not the iron. And now that connection is successful. Okay. All of the parts are now soldered. So what's next? The next thing to do is inspect your board. Make sure you have all your parts in the correct place the best you can. Make sure that all of your leads are trimmed. And then if you are using no clean solder, then you do not need to clean it off. If you're using organic flux solder, you must clean it thoroughly with hot water and dry it if you're using organic, because organic flux will actually conduct electricity. But we do not. We used rosin core solder, so we're good to go. Next step, then we'll make sure the battery switch is off, and it's actually the moment of truth. So we'll grab the battery,